Good morning, students. Till now, we have seen different life cycle models, different stages that are involved in developing a project. But now, we are going to see about coding and testing in detail. First of all, what is coding? Why do we need this? Why do we write a code? What do we do after writing a code? And all are going to be discussed in this. First of all, what are the rules that are needed for writing a for limited for a global use? The rules that list what types of data can be declared global and what can't, with a view to limit the data that needs to be defined with a global scope. There are some standard headers to precede the code for different modules. The information contained in the header module should be standard for an organization. The following will be an example for the header format in some companies that are followed. First one will be the name of the module. The next one, the date on which the module is created, author's name on whose name the module is created, modification history, if any modifications are done, what are the types of modifications done, why are they done, and all those details will be discussed in the modification history. Synopsis of the module and different functions that are supported in the module along with their input or output parameters, global variables accessed and modified by the module. That is, during the modification, any global variables are accessed and all those that will be discussed. Now, let us discuss these points in detail now. Naming conventions. The naming convention for the global variables, local variables, and constant identifiers. A popular naming convention is that variables are named using mixed case lettering. Global variable name should always start with a capital letter, and a local variable name should always start with a smaller letter. We all are familiar about naming of modules in this format. The name should be used only constant name should only be used using capital letters. Now let us see the conventions regarding error, return values, and exception handling mechanism. The way error conditions are reported by the different functions should be standard within the organization. For example, all functions while encountering an error condition should either return to 0 or 1 constantly. Now, representative coding guidelines. The guidelines that are to be followed while writing a code. Do not use a coding style that is too clever or too difficult to understand, which means the code should be easy to understand. Mainly, inexperienced engineers actually take pride in writing cryptic and incomprehensible code, that is, the code in a high level language. Clever coding should be obscure meaning of the code and reduce the code understandability, thereby making maintenance and debugging difficult and expensive. The code should be well documented. As a rule of thumb, there should be at least one comment line on an average for every 3 source lines of code. Do not use go-to statements in your code. That is, the use of go-to statements make a program unstructured. This makes program very difficult to understand and debug and maintain. Length of any function should not exceed over 10 source lines. The lengthy function is usually very difficult to understand as it is probably has a large number of variables and carries out many different types of computations. For the same reason, the lengthy functions are likely to have disproportionately a large number of bugs. The larger the code, the bugs also increases. Avoid abuse side effects. The side effects of a function call include modifications to the parameters that are passed by reference modifications of global variables and input and output operations. An obscure side effect is one that is not obvious from casual examination of code. Obscure side effects make it difficult to understand a piece of code. The other one, the final point is do not use an identifier for multiple purposes. Programmers often make use of same identifier to denote several temporary entities. For example, some programmers makes use of temporary loop variable for also computing and storing the final result. Now let us see how a code is being reviewed. Testing is an effective defect removal mechanism. However, testing is applicable to only executable code. Review is very effective technique to remove the defects from the source code. That is, once the testing is performed, if still more any other errors are there, that can be rectified through code review. A code review for a module is undertaken after the module successfully compiles. That is, all the syntax error has been eliminated from the module. Code reviews are extremely cost-effective strategies for eliminating coding errors for producing high-quality code. Eliminating an error from code involves three main activities. First one is testing, and then debugging and correcting the errors. Testing is carried out to detect if the system fails to work satisfactorily for the certain types of inputs and under any other certain circumstances. Once a failure is detected, debugging is carried out to locate the error that is causing failure and to remove it. Of the three testing activities, debugging is possibly the most laborious and time consuming activity. In code inspection, errors are directly detected, thereby saving the significant errors that would have been required to locate an error. Normally, the following two types of reviews are carried out in code of a module, that is code inspection and code walkthrough. Now let us see them in detail. Code walkthrough. The main objective of code walkthrough is to discover algorithmic and logical errors in the code. Code walkthrough is an informal code analyst technique. In this technique, a module is taken up to review after the module has been coded, successfully compiled, and all the syntax errors have been eliminated. A few members of the development team are given a code a couple of days before a walkthrough meeting. Each member selects some test cases and stimulates the execution of code by hand. Code inspection. The principal aim of this code inspection is to check for the presence of serious common types of errors that usually creep into code due to the programmer oversights and check whether the coding standards have been adhered to. A good software development companies collect statistics regarding different types of errors that are commonly committed by the engineers and identify them most frequently committed ones. Such a list of commonly committed errors can be used as a checklist during code inspection. Look out for the possible errors. Here are some list of classical programming errors which can be checked during the code inspection. Use of an uninitialized variables, jumps into the loops, non-terminating loops, array indices out of bounds, improper storage allocation and deallocation, dangling reference caused when the reference memory has not been allocated. So now let us see about testing. First of all, the aim of the program testing is to identify the defects in a program. Testing program involves providing a program with a set of test inputs and observing if the program behaves as expected. The following are some commonly used terms associated with testing. An error is a mistake committed by the development team during any of the development phases. The mistake might have been committed in the requirements, design, code, or any other stage of the project. An error is also sometimes referred as a fault, a bug, or a defect. A failure is a manifestation of an error. In other words, a failure is a symptom of an error, but mere presence of an error may not necessarily lead to failure. Test case. The test case is a triplet where I is the data input of the system, S is the state of the system at which the data is input and expected output of a system. The test suite is a set of all the test cases with which a given software product is tested. Now let us see the various let us see the differences between the verification and validation. Software verification. In this, first the verification addresses the concern, are you building, is it right? The validation addresses the concern, are you building the right thing? Which means here in software verification, it is addressing you in such a way that to think whether you are building it right or not. Whereas in software validation, it will warn you about first of all, what are you building? Is that one right or not? The next one, it ensures a software system that meets all the functionality. Whereas in software validation, it ensures that the functionalities meet the intended behavior. In software verification, this verification takes place first and includes the checking for the documentation code, etc. Validation occurs after verification and mainly involves the checking of the overall product. Software verification is done by the developers, whereas software validation is done by the testers. It has statistic activities as it includes collecting reviews, walkthroughs, and inspections to verify a software. In software validation, it has a dynamic activities as it includes executing the software against the requirements. It is an objective process and no object decision should be needed to verify a software. It is a subjective process and it involves subjective decisions on how well a software works. Now let us see the different testing activities which are involved in a project. Test suite design. The set of test cases using which a program is to be tested and designed using different test case design techniques that have been discussed later in this chapter. Now, let us see how running test cases and checking the results for perfect failures. Each test case is run and the results are compared with the expected results. A mismatch between the actual result and the expected results indicates a failure. The test cases for which the system fails are noted down for later debugging. Debugging. For each failure observed during the previous activity, debugging will identify out the statements that are in error. In this, failure symptoms are analyzed to locate the errors. Next, error correction. After the error is located in the previous activity, the code is appropriately changed to correct the error. It means if any other when the errors are identified, they first check whether which type of error it is, how to change, and if needed, they change the code to correct these errors. Testing approaches. Tests can be conducted based on two approaches: functionality testing and implementation testing. So, first, when we come to these testing, which are there of two types, that is black box testing and white box testing. So, first, let us discuss about black box testing. It is carried out to test the functionality of the program. It is also called behavioral testing. The tester in this case has to set an input values and respective desired results on providing input. If the output matches with the desired result, the program is tested okay and or problematic otherwise. This is the diagram to represent the black box testing. In this testing method, the design and the structure of the code are not known to the tester, and the testing engineers and end users conduct this test on the software. Black box testing techniques. There are some techniques in black box testing, that is equivalence class and boundary values, cause effect graphing. So first, equivalence class. The input is divided into similar classes. If one element of a class passes the test, it is assumed that all the classes are passed. Boundary values. The input is divided into higher and lower end values. If these values passes the test, it is assumed that all the values in between may pass too. Cause effect graphing. In both the previous methods, only one input value at a time is tested. That is, first it is given as input, and output effect is a testing technique where the combination of input values are tested in a systematic way. Next one will be the pairwise testing. It means that the behavior of the software depends upon multiple parameters. So in pairwise testing, the multiple parameters are tested pairwise with different values for testing. State-based testing. The system changes its state on the provision of the input, which means depending upon the input we give, the system will change the state. These systems are tested based on their states and input. The next one will be the white box testing. It is conducted to test a program and its implementation in order to improve the code efficiency or structure, which this is also known as structural testing. This is the way how the white box testing is performed. In this testing method, the design and structure of the code are known to the tester, and the programmers of the code conduct this test on a code. So here are some techniques that are used in white box testing, which is first one control flow testing and the other is the data flow testing. The purpose of the control flow testing is to set up the test cases which covers all the statements and branch conditions. The branch conditions are tested for both being the true or false so that all the statements are covered. Data flow testing. In this, it covers all the data variables that are included in the program and the test is performed on these variables and declare whether they are used or whether they can be used or changed. So that's all for today. Thank you.